In-class activity 16B. 1. How long does it take to charge your cell phone? How long does it take the battery to run out? Do these times depend on anything? Well, my phone charges in roughly, 2 or 3 hours. But if I use the charger in my car, it may take more. If I'm watching videos and charging, it's going to take longer. So no surprise there. Objectives for the activity. You will understand that the graph of a rational function appears in certain ways on intervals near its vertical asymptotes. The output of a rational function can be either positive or negative near a vertical asymptote. You will be able to find the vertical asymptotes and zeros of a rational function using algebra. Interpret the behavior of a rational function on intervals near its vertical asymptotes in the context of a model. For a discharged ideal battery, the time required to fully charge it is given by the following formula. Time is equal to battery capacity over charging current. The capacity of cell phone batteries is usually given in milliamp hours. The output current of cell phone chargers is measured in milliamps. So this formula gives the time in hours for an empty battery to be fully charged. 2. Suppose that the battery capacity of your cell phone is 3,800 milliamp hours. Part A, write a formula for the function f of x that gives the charging time of this battery as a function of the charger current x. So what we could do is just to call this f of x, so that's the name of our function, and then the 3,800 is the capacity of the battery, and the charging current is x. So there's our function. Part B, use a graphing calculator or app to sketch the graph of the function f on the interval from 0 to 6,000. Consider output values between 0 and 12. Label axes of your graph with the quantities they represent and identify the vertical asymptote of the graph. Okay, so let's go ahead and open up our calculator, and I'm going to go to the y equals screen, and let's see, I already have this graph, so let's graph this and see what happens. And we're supposed to go to 6,000, so it's just about 6,000 there. And we get a curve that looks like this. There we go. All right, let's go back and try to sketch this. And I'm just going to go scroll right here and put it here. Okay. We're going to go up to 6,000. And then there's about 3. Okay, and the horizontal axis is our charging currents. And let's go, we're supposed to go up to 12, so I'm just going to put a 12 up here, and that's about 6, 3, and 9. There we go. And this is our charging time. Let me just write that. And remembering what the curve looked like, it was coming down like this and then started to flatten out. Okay. And remember, there's a vertical asymptote is at x equals 0. So let me just, let's put a dashed line here. There's our vertical asymptote at x equals 0. Part C, let me just scroll all the way up here. I'll leave the graph there for a second. A local electronics store sells several different phone charges rated from 1,400 milliamps to 4,200 milliamps. What is the range of charging times that corresponds to this selection of phone chargers? Okay, so if we can actually use the graph that we just drew, and If we think about 1400, let's see, or let me just go to the calculator and we'll calculate these directly. Okay, so if we take 3,800 and divide that by 1,400, we get 2 5/7, and I'll even get a decimal here, approximation. It's about 2.7. And what was the other one we had? We had 3,800 divided by 4,200, 19/21. Let's get an approximation of that as well. About 0.9. All right, so back to writing. If we took what? The first one was 3,800 over 1,400. And we got about 2.7. I'll use the approximation. And then we have 3,800 over 4,200. And we got about 0.9 roughly. All right, part D. Let me start there. If you use a USB charging cord to charge your phone from another device, such as your computer, the current is fixed at 500 milliamps. How long would it take to fully charge your cell phone in this situation? Well, let's say if we take, let me just squeeze this in here, f of 500, and then we still have 3,800 for the numerator, and then the denominator is 500, and 3,800 divided by 500, let's try that. All right, 7 3/5. That's the same as 7.6 if we use a decimal. So it would take around 7.6 hours. Wow, okay. Part E, a convenience store sells inexpensive chargers with current ratings below 400 milliamps. Would you buy one of these? Let's see, below 400. Well, it's going to take an incredible amount of time to charge your phone. So even if we use 400, f of 400, 3,800 over 400. Nine and a half hours. Wow. Maybe not the best. Let's go to part 3 and scroll all the way up here. It says Maurice needs to charge his cell phone, but he wants to watch a video while his phone is charging. Okay. The phone requires 600 milliamps of current to display the video, and the battery capacity of his phone is 3,200 milliamp hours. If X represents the charger current in milliamps, then the current available to charge his phone is X minus 600, okay, milliamps. Therefore, the time it takes for Maurice's phone to charge is given by the following function. G of X equals 3,200 divided by X minus 600. So for part A, it says the graph of G has a vertical asymptote. Where is it? And then Maurice used a charger with a current rating. If Maurice used a charger with a current rating at this asymptote, what would happen? So let's just draw a quick sketch of what's happening here. So at 600, we are going to have a vertical asymptote. Let me just draw a dashed line here. Okay, go back to blue. So this is 600. So there's our vertical asymptote. The curve is going to look pretty much like the other curves we had. It's going to come down and go like this. And then we also have a curve like that. So the question says, if Maurice used a charger with a current rating at this asymptote at 600, what would happen? Well, there's a vertical asymptote at 600. So if Maurice used a 600 milliamp charger, the current being used for the video would cancel out the current being drawn from the charger, and his phone would never charge. All right, so part C. As a positive value of G models the time it takes for an empty battery to charge, a negative value of G can model the time it takes for a full battery to discharge. For what values of G, or excuse me, for what values of X is G of X negative? So the function G of X is negative. Okay. When X is strictly less than 600. All right, let's go to part D. Part D starts out by saying, what if Maurice starts with a full battery and watches videos while charging with a 500 milliamp charger, will he be able to finish a full-length movie? Yes, he would be able to finish a movie. A current rating of 500 milliamps is very close to the asymptote, so the time to discharge is very large. Okay, so we'll put yes here. He will be able to finish his movie. There we go. Part 4. Bigger phones and tablets can have bigger batteries with more capacity, but the larger screen takes more current to operate. Let S represent the diagonal screen size in inches. Suppose that a mobile device with screen size S can have a battery capacity 800 S minus 1200 milliamp hours. Suppose also that watching a video on this screen requires a current of 24 S squared milliamp hours. Using a 2400 milliamp charger, the time T of S in hours to charge a mobile device with screen size S inches while watching a video is given by the formula T of S is equal to 800 S minus 1200 over 2400 minus 24S squared. Part A. The graph of T has two vertical asymptotes. Where are they? Do they correspond to reasonable screen sizes for a mobile device? Well, if we look at the denominator and we have 2400 minus 24S squared, and we set that equal to 0. Okay, so continuing here, if we solve this, we're going to solve for S. So we'd get 24S squared equals 2400. Then S squared is 2400 over 24. So S squared is equal to 100. So S is going to be plus or minus 10. Okay, so do they both of these answers correspond to reasonable screen sizes? Well, the 10 does. We could have a screen size that's 10 inches diagonal, but a negative screen size doesn't make any sense. So the 10, positive 10, yes, negative 10, no, that doesn't make any sense. Moving on to part B, use a graphing calculator or app to sketch a graph of the function t on the interval 0 to 16. Include any vertical asymptotes on your graph and label the axes. Okay. All right, so let's go to a calculator. Y equals, I have this entered in already in Y1, and let's graph this. And there we go. We see our vertical dotted line, the asymptote, at x equals 10. And then we see the two curves, one to the left, one to the right of the asymptote. So let's go back to try to sketch this. There we go. Vertical axis, horizontal axis, and this is going to be the time in hours axis, and this is the screen size axis, and we're in inches. Okay, x equals 10. We had an asymptote, so I'm just going to sketch that in here roughly. So there's x equals 10. Let me go back to the blue pen. We get a curve like that. And a curve like that. Part C, let's move this up here. A modern smartphone has a diagonal of at least 5 inches. Use your graph from part B to give an approximate answer to the following questions. What interval of screen sizes would allow the mobile device to recharge in a reasonable amount of time while watching a video? Well, the interval, or S, is between 5 and 7. That would allow a charging time that's less than 4 hours. You might want to go back and look at the graph for that. So if we see on the x-axis 5 to 7, and we trace that up to the curve, then we're definitely either of those, any that we're in that interval from 5 to 7 on the x-axis, that's going to be less, the output will be less than 4 hours. So that's reasonable. Let's go back to where we were. Next, it says for what interval of screen sizes would the mobile device keep its battery charge approximately the same time while watching a video with the charger connected? And when we're fairly close to the asymptote, so in the interval, we could say maybe 9.5 to 10.5 inches. Okay. And for the last part here, it says for what interval of screen sizes would the mobile device noticeably lose battery charge while watching a video with the charger connected? And let's see anything. Let's do this. I'm going to go back and look at the graph again. How about pick 13? So we'll go back here and we'll say, how about interval when S is larger than 13? Right, that's the end of this video.